Thank you for attending my sunroom chat. Today I will discuss electricity in terms of virtual elastic string theory. Scientists have shown that electric fields come in two forms, positive and negative, as shown in the next slide. Here we see there is a strong force of attraction between a negative and positive electric field. However, when two identical fields meet, there is a force of repulsion between the two particles. This is true for both positive and negative electric fields. Here we see an electron surrounded by a negative electric field. The field is composed of virtual elastic strings. The individual strings are called anilons. The electron creates a vast number of anilons. I use the term elon for the string that makes up the electric fields. Elon is analogous to graviton, the term used by scientists for the entity that creates a gravitational field. Another important concept is this: the electric fields about an electron are not constant. Namely, virtual elastic strings are always created in cycles. The electron string cycle occurs billions of times every second. There is a time when the electron is creating strings and a time it is retracting those strings back to their source. This virtual elastic string cycle is repeated over and over billions of times every second. This causes diatomic molecules to pulsate rapidly as they separate and then snap back together. Now let's examine the force fields of a proton. A proton is a particle that emits a positive electric field. The field is actually created by quarks inside the proton. I'll come back to the origin of the proton's electric fields when I discuss quarks. A proton creates p-elons that make up the positive electric field. A proton is constantly making and retracting its positive virtual elastic strings. The string cycle of a proton occurs billions of times every second in the same manner as electrons. As you can imagine, there must be a strong force of attraction between a proton and an electron. The force of attraction allows the electron to remain in orbit about the proton, and it allows protons and electrons to combine and form the atoms, molecules, and compounds that make up our world. In the next slide, I have illustrated the force of attraction between the electron and proton using the hydrogen atom. Hydrogen is the least complex atom. It is composed of just one electron and one proton, as shown in the next slide. A force of attraction is created between electron and proton when the complementary strings bond, then retract back to their sources. Perhaps bonding is due to some form of entanglement between complementary strings. Negative electric strings, that is, the anilons, made by the electron become bonded, as I said, perhaps entangled, with the positive electric strings, the p-elons, made by the proton. When the bonded elons retract, it creates a strong force of attraction between electron and proton. It is this force of attraction that keeps the electron in orbit about the proton. A force of attraction between two particles requires a source of energy. Where does this energy come from? It all begins with the creation of the virtual elastic strings by subatomic particles. The particles that create virtual elastic strings are electrons, photons, and the quarks found inside protons. I have illustrated the creation of a virtual elastic string in the next slide. The electron ejects a virtual particle with great velocity. Because the virtual particle remains attached to the electron, a virtual elastic string is created in its wake. The energy of the virtual particle is transferred to the elastic string that it stretches out through space. The stretch placed on the elastic string dictates the potential energy stored in the string. Anilons and p-elons are complementary strings that create the electric fields. The two strings have the same mass, but differ in some other property when extended in space that allows the two strings to bond and create a force of attraction. It is possible that bonding is due to some form of entanglement between complementary strings, but not between identical strings. Now I want to turn your attention to the repulsion forces between two electrons. Repulsion occurs because identical strings do not bond in the same manner as complementary strings. This leaves the virtual particles free to create a force of repulsion against opposing electrons as shown in the next slide. The virtual particles are ejected from the electron with great velocity. The particles are composed of matter and they have momentum. The collision between virtual particles and electrons drives the two electrons apart. In this manner, the virtual particles create the force of repulsion between electrons. Let me emphasize two important points. Identical strings do not create a force of attraction because they do not bond in the same manner as complementary strings. The momentum of the virtual particles slamming into the opposing electrons is the source of the repulsion between electrons. The force of repulsion between two electrons is calculated using the same equation used to calculate the force of attraction between electron and proton. This seems rather strange, but elastic string theory explains it easily. The force of repulsion and the force of attraction are both dependent upon the momentum of the virtual particles. In the case of attraction, the momentum of the virtual particles stretches the elastic string out in space, and in this manner it is responsible for the potential energy stored in the string. In the case of repulsion, the virtual particle's momentum is responsible for blasting two electrons apart. For this reason, the same equation can be used to calculate electrical repulsion and attraction. The energy comes from the virtual particles hurled into space by electrons, photons, and quarks. On this slide, I have summarized some of the key points of today's discussion. Electrons create negative virtuoelastic strings, the anilons. Protons create positive virtuoelastic strings, the p-elons. The two elons are viewed as having the same mass but different structures or orientation in space. The two are complementary strings that likely bond because they become entangled. When complementary strings meet, bond, and then retract, they create a force of attraction between particles. Identical strings do not bond in this manner. This allows the virtual particles to create a force of repulsion between two electrons. Electric forces of repulsion and attraction are both dependent upon the momentum of the virtual particles. This is the reason the same equation can be used to calculate both forces. Thank you for joining me in my sunroom chat. I will continue with the electric force fields when I examine the positive and negative currents found in a wire, the topic of my next sunroom chat. A brief message will follow, and I hope you are having a nice day. Thank you.